All right, so you're here with us because you want to get smart, fast, right on all these new technologies coming out. You want to cut through the noise and really get to the core of what's important.
Yeah, that's the goal.
Well, today we're diving deep into a blockchain that's making waves with, like, a really different way of doing things. The SUI blockchain.
It's a fascinating one for sure. I mean, there are just so many layer one platforms out there.
Yeah.
But SUI has really caught people's attention because they're trying to solve, like, the fundamental problems of scalability and speed, you know?
Yeah. And we're going to try to break down exactly how they do that, right?
Absolutely. Consider this your insider's guide to the key innovations that set it apart.
So our mission today, if you will, is pretty simple: to dissect those core technical things that make SUI unique. And we'll get to the why it matters part two, don't worry. We're basing this deep dive on the material you sent over, SUI blockchain, architecture and technical innovations.
It's some really insightful stuff.
Yeah.
And it's a really interesting story, too, actually. SUI comes out of Miston Labs, founded in 2021 by this team that came from, like, Meta, right?
Mm.
So these are people who've been deep in the world of blockchain development.
Oh, wow.
They basically set out to create a platform that was robust enough, you know, really up to the task of supporting the next wave of Web3 applications. I'm talking about everything from DeFi and NFTs to, you know, those really immersive gaming experiences.
So not just like tweaking around the edges. This is like a from the ground up kind of redesign, right? Like they're calling it like a next gen blockchain, aiming for a serious boost in speed, making it better for everyone, users, and the people building on it. So let's like unpack this.
Yeah, let's do it.
Where do we even begin to see how SUI is built differently?
Okay, so a really good place to start is with how SUI actually organizes data. So unlike, say, Ethereum, you know, Ethereum uses this account-based structure. You have your account, it holds your assets, your balance. SUI, though, they use something called an object-centric data model.
Object-centric. All right, so instead of focusing on accounts holding balances, we're looking at individual objects. What does that even mean, like, in practice?
So yeah, on SUI, everything is treated as a unique, distinct object. So your tokens, your NFTs, even the smart contracts themselves, all individual objects. Each object has its own specific properties and a clear owner. So an object could be owned by an address, could be shared among multiple users, or even be immutable, right?
Yeah.
Which means its properties are fixed and can't be changed.
Okay, I'm getting this picture of like a digital space made up of these individual identifiable building blocks, right?
That's a really good way to put it.
But how does this whole object-centric approach make SUI better? Like, what's the real advantage?
The main benefit, especially for common everyday transactions, is that it cuts down on complexity a lot. So let's say you transfer a token on SUI. The system only needs to update that one token object, its state, its ownership. You don't need to update this massive interconnected ledger like you might on an account-based system. It just streamlines things.
Oh, I see.
It really cuts to the chase.
So for those routine transactions, it's just more direct, more efficient.
Exactly.
Now, the material we have also mentions Move, the programming language SUI uses. That seems like a pretty important piece of this whole thing, right?
Oh, absolutely. Move is fundamental to SUI's architecture. It was originally developed by Meta, actually, for their DM project, and it was built with a huge focus on security. And it has roots in the Rust programming language.
And security is, you know, like the biggest deal when we're talking about people's digital assets, right?
It is.
So how does Move specifically make things more secure?
So the really interesting thing about Move is that it enforces the rules of asset ownership right there in the programming language itself, like baked in.
Oh, okay.
It has these mechanisms that prevent those really common vulnerabilities like double spending, where someone tries to use the same digital currency multiple times, or those reentrancy attacks, which are ways people can try to drain funds from smart contracts.
Right.
So you're basically preventing those issues from the get-go because of how the language is designed.
Yeah, okay. That sounds like a huge win, both for developers and the people using the applications, right? Like fewer weak points to worry about. And the source mentions it gives developers more flexibility, it makes things safer for them to build.
It does. Move gives them this really solid base to build on so they can create these sophisticated, decentralized applications, dApps, as they're called, with way more confidence that their code isn't going to be vulnerable to those like critical security flaws.
Awesome. So we've got this object-centric model and a programming language that's all about security. Now, the big thing people talk about is speed. And the source emphasizes this idea of parallel transaction processing, which sounds like a big deal. Most blockchains are like a single lane road, right?
Yeah, that's a really good way to think about it. Most blockchains are stuck processing transactions one by one sequentially. But SUI does it differently. It categorizes transactions, and it can process a bunch of them at the same time in parallel.
How does it choose which transactions get to use this, like fast lane?
Okay, so SUI mainly deals with two types of transactions. You got your simple transactions, things like sending SUI tokens from one person to another.
Right.
These usually don't depend on the state of other objects on the network. And because of that, SUI can process them super fast and all at the same time using its Narwhal and Bullshark engines.
Narwhal, Bullshark, we'll get to those.
We will.
Yeah.
But think of it this way. For the simple stuff, the network doesn't need everyone to agree in a big, long process, full consensus. Instead, it can be like a smaller group, making decisions quickly for these simple actions. That speeds everything up.
So like a quick check-in rather than a whole board meeting?
Exactly.
Got it. So basic transfers and swaps get the express treatment. What about the more complex stuff?
Right. So for complex transactions, things you'd see in DeFi, like exchanging one crypto for another on a decentralized exchange, those usually involve shared objects, things like liquidity pools. And those transactions need more coordination, so they go through a consensus mechanism.
So like if I'm just voting in a simple on-chain poll, that's probably a simple transaction.
Yeah.
Whereas if I'm taking out a loan on a DeFi platform, that's complex, with lots of moving parts and different things happening.
Yeah, you got it. And even the complex stuff gets processed, but the simple, everyday things just happen really, really fast. Like the source mentioned some pretty impressive transactions per second numbers.
It did. It did.
Yeah, like way faster than what you'd see on other platforms.
Give us the numbers.
Okay, so in testing environments, SUI has shown that it can handle over 120,000 transactions per second. And like in bursts, it's gotten close to 300,000. To put that in perspective, Ethereum, a big platform, it usually handles around 15 transactions per second.
Wow, okay.
So while real-world usage might not always hit those peak test numbers, the potential is definitely there, right?
Yeah.
I mean, think about what's possible when transactions are this fast. Like, suddenly we could have applications on the blockchain that feel as instant as, regular web apps.
That's wild.
Imagine decentralized games where every action you take has immediate feedback, or those tiny micropayments happening smoothly without the lag and cost we're used to.
Okay, mind blown. Officially mind blown. But okay, this network still needs to be secure, right? The source talks about proof of stake with delegated consensus. Is that like the standard model these days?
Yeah, delegated proof of stake, DPoS, is pretty common in a lot of blockchains now. So in SUI, people who hold SUI tokens, they can stake them with validators.
Right.
These validators are the ones processing transactions, keeping the network secure, and they get rewards for doing that.
Right.
And it's generally seen as more energy efficient than the older proof-of-work systems that some other blockchains use.
So your tokens are basically doing work, helping run the network.
Right.
But the source mentioned this interesting thing about SUI bypassing full consensus for simple transactions. How does that work?
So this is where SUI's architecture really shines in terms of speed. For those simple, independent transactions, remember those.
Yeah.
SUI doesn't need to go through a full-blown consensus round with all the validators. It uses something called Byzantine Fault-Tolerant Broadcast, or BFT. It's basically a more streamlined process to agree on those simpler things. It's only when transactions involve those shared objects that SUI brings in the bigger, more robust Bullshark consensus algorithm to get everyone on the same page, make sure everything's in the right order.
So different levels of agreement depending on how complex the thing is.
Exactly.
Got it. Now, you've mentioned Narwhal and Bullshark a few times. Those seem to be at the heart of how SUI does what it does.
They are.
Can we dig a little deeper into those?
Okay, so Narwhal, think of it as SUI's super efficient system for making transaction data available across the network. It's their mempool, basically. What's really innovative is that Narwhal separates the job of spreading that transaction data from actually figuring out the order of those transactions. It's like having this perfectly organized filing cabinet where transactions get stored and shared really quickly.
Okay, so Narwhal's like the super fast messenger, getting the transactions where they need to go.
Exactly. Yeah.
And what about Bullshark? What's its job?
So Bullshark is SUI's consensus engine. Its main role is to put those complex transactions, the ones with shared objects, into the right order. And Bullshark is actually an improvement on an earlier mechanism called Tusk. It's designed to be even more powerful and resilient.
Okay, so Narwhal gets the information out there quickly, and Bullshark makes sure the complex stuff happens in the right sequence.
Yeah, perfect.
The source mentions this leads to horizontal scalability. What does that mean for the network in plain English?
So horizontal scalability means that as the network gets bigger, as more validators join, it can actually handle more transactions without slowing down. Because of how Narwhal and Bullshark split up the work, adding more validators just adds more processing power. So the network can grow and get faster at the same time.
That's pretty impressive.
It is.
A blockchain that gets faster as it grows, that's pretty cool.
Yeah.
Now let's talk about cost. The source mentions gas fees and the SUI token. Right.
What's the deal with the fees on SUI?
So SUI is the native token of the SUI blockchain. It's used for two main things: paying for gas fees, which are the costs of doing transactions, and for staking, in that delegated proof-of-stake system. What's interesting about SUI's fees is that they try to be predictable and keep costs low. They use this market-based pricing model where validators actually help set the reference prices for gas based on how much computation and storage is needed.
So it's not just a fixed fee?
No, it's dynamic.
Okay, and how does that benefit users?
Well, because the fees are adjusted by the validators, it helps avoid those crazy spikes in gas prices that you sometimes see on other blockchains when the network gets really busy.
Yeah.
This predictability and generally having lower costs is really good for both users and developers. Nobody likes surprise fees, especially when things are already hectic.
Exactly, especially when you're trying to do something quickly. All right, so we've covered a lot of the tech behind SUI.
We have.
Can we walk through a couple of examples to see how all this works in practice? Absolutely.
Let's start with something simple, like sending some SUI token.
Okay, so imagine you're sending 10 SUI to a friend.
Okay.
This is a simple transfer, just involving your SUI token object and your friends.
Right.
So the validators quickly check that you own the tokens, the transaction gets broadcast using Narwhal, and boom, it's done. It's final, meaning it's confirmed and irreversible in less than a second. And the best part, it doesn't require a huge update to the whole global ledger.
Wow.
It's just those SUI token objects that get changed.
That's crazy fast. Okay, what about something more complex, like a trade on a DeFi platform?
So for a trade, let's say you're swapping one crypto for another on a decentralized exchange.
Yeah.
You're usually interacting with those shared objects, like the liquidity pool that holds the different assets.
Right.
And because it's a shared object, the Bullshark consensus engine comes in to make sure that your transaction is put in the right order with all the other interactions happen with that same pool. So it's a bit more complex than just sending tokens. But SUI still manages to finalize things really quickly, usually under 2 seconds.
Still way faster than on other platforms.
Oh, yeah.
It seems like this two-pronged approach, like super fast for simple stuff, still pretty fast for the complex stuff, that's a major difference.
It is. Being able to handle tons of simple transactions almost instantly, but also process complex ones efficiently, that's at the heart of what SUI is trying to do. It's how they can support all these different Web3 applications.
Okay, so based on everything we've talked about, what are the main reasons SUI stands out? What are its, killer features?
Okay, so I'd say there are 3 big things. First, SUI's got scalability built right in at layer 1 through parallel processing. Unlike platforms that rely on layer 2 solutions like rollups to handle more transactions, SUI is designed from the ground up to scale. It can process lots of things at once, and it can get even more powerful just by adding more hardware, more validators.
So scalability, that's part of the DNA, not an add-on.
Exactly.
Okay, what's the second big difference?
The second one is user experience, specifically that near-instant transaction finality. For a lot of real-time applications, think blockchain games, or even just minting an NFT waiting around for things to happen like you do on other blockchains, that's a big turnoff for people. SUI's speed means things are much smoother, more responsive. It's closer to what people are used to from regular web apps.
Yeah, who wants to wait minutes to do something in a game?
Nobody.
Nobody. All right, what's the third key differentiator?
The third one is developer friendliness, and that comes from the object-centric model and the Move language. The way Move works with objects, it leads to cleaner, shorter code, which means there are fewer chances for security problems to creep in. Just makes the whole development experience better. Move is designed to avoid common vulnerabilities so developers can focus on creating cool stuff instead of constantly worrying about patching security holes.
So faster, smoother, easier to build on. That's a pretty strong combination.
It is.
Now, how's all this translated into real-world performance, and how's the ecosystem growing around SUI?
So SUI's mainnet launched in May 2023, so it's still pretty new, but it's grown a lot really quickly. By late 2024, it had already reached a market cap of $5.7 billion, according to CoinMarketCap. and there are over 200 decentralized applications built on it.
That's pretty impressive growth in a short time. What about those super high TPS numbers we talked about before? Is the network actually handling that much traffic in real life?
Well, those peak numbers, the 297,000 transactions per second that Misten Labs hit in testing, yeah, those were under ideal conditions. In the real world, it's not quite that high yet. But even so, SUI's transaction throughput is still way better than most established blockchains out there.
Okay, and where are we seeing the most action in the SUI ecosystem? Like what kinds of applications are taking off?
So DeFi is definitely a big one. Projects like FlowX are gaining a lot of traction. FlowX is using SUI's speed to make cross-chain transfers faster and liquidity provision more efficient. And the NFT space is heating up too, with marketplaces like Bluemove doing well. And like we talked about before, blockchain game developers are really liking SUI because of its speed and low costs. So we're seeing a lot of new game-related dApps popping up.
It sounds like those core strengths of SUI, the speed and low fees, those are really pulling people in.
They are.
Okay, but every technology has its challenges, right? What are some of the hurdles or trade-offs SUI is facing right now?
Oh yeah, definitely. So one thing is the learning curve for developers. If they're already used to languages like Solidity, which is what you use on Ethereum, SUI's object-centric model, and the Move language, they require a different way of thinking about things, a different way of writing code.
So it's like learning a new skill, basically.
It is, yeah. Another thing is decentralization. When SUI launched, it had about 100 validators securing the network. It's a decent number, but it's still lower than more established blockchains like Ethereum, which have thousands of nodes. SUI has the potential to become more decentralized as it grows, but it's something to watch. More nodes generally mean a stronger, more resilient network.
Yeah, more people participating usually means more security, harder to take down. Any other challenges?
Yeah, so another factor is just how widely adopted the Move language becomes. It's a really powerful language, secure, but it's not as popular as Solidity yet. For SUI to really thrive, it needs to keep attracting developers who are willing to learn Move.
So it's a bit of a chicken and egg situation, right?
It is.
Yeah.
The more developers use Move, the more successful SUI becomes, and the more attractive it is for other developers to learn Move.
Yeah, that makes sense. Okay, as we wrap up, what's the big takeaway here? What's the driving force behind SUI?
I think at its core, SUI is really about rethinking how we build blockchains. It's not just about making small improvements to existing systems. They're trying to build something completely new, something that can support Web3 applications that are as fast and seamless as the regular web apps we use every day. Whether it's trading on a DEX, minting an NFT, playing a blockchain game, SUI wants to make those things feel instant, secure, and able to scale up without limits.
It's about bridging that gap between Web 2 and Web 3. That's ambitious.
It is. And all the technical innovations in SUI, the object-centric model, Move, parallel processing, they're all working together to try to make that vision a reality.
You've given us a lot to think about, that's for sure. A really insightful deep dive into how SUI works. It's clear they're doing things differently, trying to solve those fundamental problems in the blockchain space.
Yeah.
So for everyone listening, hopefully this has helped you understand SUI better, cut through the complexity and see the key innovations at work.
Yeah, that's what we aim for.
Now, while you're thinking about all this, consider this. How might SUI's approach with objects and parallel processing affect the future of decentralized applications? And could it even teach us something about other areas of computing that deal with managing data and doing lots of things at once? You might even be interested in checking out the Move language itself or exploring some of those innovative dApps on SUI.
That's a great point.
There's definitely a lot to explore there. Thanks for joining us on this deep dive. Hopefully it's made you curious and given you a shortcut to understanding this technology. Until next time, keep learning.